Let's do this one together. We'll get our brains energized. What's the first thing we got to do? How do we solve this first part? How do we find the derivative of it? Using what method? Differentiation is a derivative. What's it called? The product rule. Remember we have the f and g, and we find the f prime, g prime, and we do the fishy thingy. So the f part is x squared, and the g part is y. So the derivative of x squared is 2x. The derivative of y, very good, dy dx. So for this first part, we have y times 2x plus x squared times dy dx. So that's the derivative of this first part. We've got to do the same thing now with the second part. Derivative of x, 1. Derivative of y squared, excellent, 2y dy dx. Anytime you take a derivative of y, put a dy dx behind it. We have y squared times 1 plus x times 2y dy dx. It's that part. Equals the derivative of 6, 0. The derivative of any constant is 0. It looks difficult. It looks long and drawn out. You see a lot of symbols up there, but it's really all algebraic from here on out. What do we have to do now? What are we solving for? dy dx. We have to isolate dy dx on one side and then everything else on the other. All right, so that's it for today. Just kidding. So everything has dy dx, we leave over here. Everything that doesn't have dy dx, we move to the other side. So we have to subtract xy 2 and y squared. 2xy minus y squared. Negative 2xy minus y squared. How do we get dy dx alone? What did you call it? Sure. Yes. Yes. Since both of these have dy dx in them, we can factor it out, leaving their coefficients. X squared plus 2xy equals negative 2xy minus y squared. Last step. What do we have to get rid of? Yeah, this whole thing here. How do we get rid of it? Divide. Divide both sides by x squared plus 2xy. There's our derivative. What do y'all think? Pretty easy so far? Let's just go straight down the odd numbers. See, let's look at number 2, because it's got x's and y's on both sides. So does that one. Which one do you do, 2 or 3? Oh, yes. Good choice, good choice. Yeah. X cubed plus y cubed equals 18xy. Find dy dx. Oh, across the board. Derivative of x cubed. 3x squared. Derivative of y cubed. 3y squared. And what else? dy dx. Anytime you take a derivative of y, put dy dx. That's what we were just talking about earlier. Since this is a coefficient, you can treat them both separately. But it's going to factor out anyway. So we just have to take a derivative of this part and put it in here. So f and g, f prime, g prime. X, y. Derivative of x is 1. Derivative of y is dy dx. I times 1 is y plus x dy dx. Since there's a dy dx inside the parentheses, we have to distribute to get rid of that parenthesis anyway. (18y, 18x, dy dx). What do we move? There's no wrong answer here, because you either move this one to that side or that one to this side. Which one do you move? Okay, let's move this one. Let's subtract 18x dy dx from both sides. (3x squared, 3y squared, dy dx minus 18x dy dx equals 18y, because these are gone. Get rid of the non-dy dx. Subtract 3x squared both sides. 3y squared dy dx. 18x dy dx. 18y minus 3x squared. Since both of these terms have dy dx, we can factor it out, leaving just the coefficients. Since they're multiplied, we got to do the opposite and divide. dy dx equals 18y minus 3x squared, 3y squared minus 18x. A commutativity, you can move them around if you want to, make it look nicer. So far, so good? Let's crank it up to 11. Or 9.5. We're going to do number 5. X squared, x minus y squared equals x squared minus y squared. Find dy dx. This side's going to give us some trouble because it's the product rule with a twist. So f is x squared, g is x minus y squared, f prime is 2x, g prime. How do you take a derivative of this one? We take the derivative of the outside, which is 2x minus y, subtract 1 from the top, times the derivative of the inside. Derivative of x is 1 minus the derivative of y, dy dx. Yeah, we could distribute that. We have 2x minus 2y, 1 minus dy dx. Eventually you have to multiply these together. So let's see. This one's going to be x minus y squared times 2x plus x squared is 2x minus 2y times 1 minus dy dx equals the derivative of x squared is 2x. Derivative of y squared, 2y dy dx. So far, so good? I see a lot of writing. All right, so now let's get rid of the parentheses. What do we do here? What do we do with this first one? Or do we have to combine them since there's no dy dx in there? We leave them as they are. We're interested in this dy dx's right here. So we do have to multiply all those together. We can leave this alone the way it is. X minus y squared, 2x. Let's say we did. Let's say we did want to multiply these together. How do we do that? What do we have to do first? We'd have to take x minus y times x minus y. We have to FOIL those together first. X squared minus 2xy plus y squared. And then distribute to y squared, to 2x. So that's what that 2, we have to, it'd be x minus y times x minus y. But we do have to multiply these together. 2x cubed minus 2x squared y dy dx x minus y squared, 2x, 2x cubed, 2x cubed dy dx, 2x squared y, negative negative is a plus, 2x squared y dy dx. Yeah, the step by step, see if everyone's there. This is very easy because the signs you could miss a sign up, you could by accident forget to put one of the terms there. So you have to be very, very, very careful what you do here. Well, I think we're going to have to multiply these together because that way we can combine like terms. X minus y times x minus y times 2x. This becomes x squared minus 2xy plus y squared. Distribute. 2x cubed minus 4x squared y plus 2x y squared. That's just this first part right here. Plus 2x cubed minus 2x cubed dy dx, 2x squared y, it's 2x squared y dy dx, 2x minus 2y dy dx. So can we combine anything? Two x cubed makes it 4x cubed. Do we have any x squared y's? Minus 4x squared y minus 2x squared y is minus 6x squared y. Two xy squared. Then our dy dx's. 2x cubed dy dx, 2x squared y dy dx, 2x minus 2y dy dx. Okay, just a little bit smaller. Now what? Let's put the dy dx's to one side, everything else to the other side. So you have minus 2x cubed dy dx plus 2x squared y dy dx And we have to add 2y dy dx to this side. All of this has to go to the other side. Minus 4x cubed plus 6x squared y minus 2x y squared plus the 2x. Now we have to get the dy dx's by themselves, so we factor them out. We have 2x cubed plus 2x squared y plus 2y equals negative 4x cubed 6x squared y 2xy squared plus 2x. Divide by this. Can we do anything to this side? Anything factor? For 2. Fortunately, that one doesn't have an x. Or take a couple of vowels. What was difficult about that one? Besides just the size of it. I mean, the problem with this is losing track where you are and what you're writing. It's very easy how this one's exploded really fast to lose track of mi dy dx dx x squared y squared. That's where the biggest mistakes happen. Make sure that you have them so when you combine like terms, you can combine like terms. Pick that one. They're fired. Have we got this? Let's do a rational one. Number 7. Derivative of y squared. 2y. dy dx. Now this side, we have f is x minus 1, g is x plus 1. F prime is 1, g prime is 1. That's x plus 1 times 1, which is x plus 1, minus x minus 1 times 1. All over the bottom squared. So we get rid of the parentheses on top. X plus 1 minus x plus 1. X's cancel. Plus 1 is 2. Plus 1 squared. One more step. What is it? Get rid of this. How do we get rid of that? Divide by 2y. dy dx. The 2's cancel, leaving 1 over y, x plus 1 squared. Can anybody tell me why I just put 2y over here? Whenever I divide, I'm actually multiplying by 1 over 2y. That's what I did over here. If I multiply 1 over 2y, it goes there. It just multiplies to it. So there's my derivative. We could go one step further. Do we know what y is? We can figure it out. We know y squared equals that. So y would equal the plus or minus the square root of this whole thing. But that's good enough for me right now. I'm happy there. Okay. Since you guys are asking for it, I'll give you one. Trig function. The way I sound. If you don't remember the derivative of secant, what is secant? Secant is, it's one of the reciprocal functions. They can't start with the same letter, so what other letters does not start with an S? What other word? Okay, let's go on. So, secant y is 1 over cosine y. So it's the quotient rule. We have to do the fishy thingy. What's the derivative of 1? 0. Derivative of cosine y. Negative sine of y. What else? Pause. It's live. It's live paused. So the derivative of 1 is 0. Derivative of cosine is negative sine y. But this is cosine u. Since y is a function of x. So we have to go the derivative of cosine times the derivative of y. It's cosine u du. So there's that part. So we do the fishy thing now. The derivative of x, 1. Cosine y times 0 minus 1 times negative sine y dy dx all over cosine squared y. That's 0. That becomes a plus, so it's 1 equals sine y dy dx over cosine squared y. Well, this got to the side here, dy dx. How do we get rid of this? I multiply, since they're multiplied, I have to multiply by cosine squared y and divide by sine y, both sides. Let's cancel. Cosine squares cancel. So dy dx equals cosine squared y sine y. We're not done yet because of the trig identities. Cosine squared is cosine y times cosine y over sine. What is cosine over sine? Cotangent. Cotangent y times cosine y. Okay. We haven't done one with e. E to the power 2x equals sine x plus 3y. But I want to do a lot more. There's a couple more problems I want to do before it gets too late. All right. Here's another rule. If the equation equals EU, the derivative is EU du. What does that mean? That means the derivative of E is simply E itself. But if there's an equation up here, it's E to that equation. The only thing you have to do is take the derivative of that exponent. So, the derivative of this equation is E to the power 2x times the derivative of 2x, which is 2. You see how it works there? So if we had e to the power 2x, that's our u. So the derivative of this is leave eu alone times the derivative of the exponent. Same thing here. This is sine u. The derivative of sine is cosine, the argument alone, times the derivative of what's inside here. Derivative of the argument is derivative of x is 1. Derivative of 3y is 3 dy dx. Everybody follow that? Kind of looking at some deer waiting for the truck to come. Since I'm solving for dy dx, I have to get rid of the parentheses. So we have 2e to the power 2x. This coefficient distributes to both of those. So we have cosine x plus 3y times 1 plus 3 cosine x plus 3y dy dx. The non-dy dx to the other side, so we subtract both sides with this. Two minus cosine x plus 3y is equal to 3 cosine x plus 3y dy dx. One more step. What is it? Trying to get this by itself, so we have to get rid of the coefficient. Divide both sides by 3 cosine x plus 3y. Where are you all getting mixed up at, snagged at? See if we can narrow that down and we can fix it. Oh, yeah. If you trip on the first step in the race, you can't win. Right. So what part do you mess up in the first step? Oh, no. Yes, I mean, sometimes it's just that simple. You just take this, multiply it to both of those. The problem some people have is this part here, is if there's a single x, they think there's nothing there. It's gone. There's no more x. They don't put the 1 there.
Everything, it's the algebra that always gets me.
Amen.
Getting to the point where I need to get dy dx by itself, sometimes that part trips me up a little bit.
Yeah, and 90% of calculus is algebra. It's calculus is the first start. The first step is calculus, and the rest is algebra. And you're right. Every rule you learn in algebra now comes in play. So yeah, that's very true for everybody across the board. Oh, yeah, that's right. Right, it should be T. It's a silent E. You're right. The answer is 2e to the 2x minus cosine x plus 3y. Good catch. Thank you. Which goes back to show you, you have so much writing to do that it's so easy to lose track of one thing or two things. The signs are the first killers. I just forgot the E. Very good catch. Okay. How about number 17? Theta to the power 1/2 plus the radius to the power 1/2 is equal to 1. Find dr d theta. So the theta is the x, the r is the y, which means anytime we take the derivative of r, we have to put what behind it? Dr d theta. That's what we're looking for. So when we take the derivative of theta, let's just take the derivative of theta. So what's the derivative of theta to the power 1/2? And subtract 1, which makes it negative 1/2. Same thing with the r. And subtract 1, which is 2 over 2, makes it negative 1/2. Derivative of 1 is 0. And I can put dr d theta here. This one is written 1 over 2 theta to the power 1/2 plus 1 over 2 r to the power 1/2 dr d theta 0. Solve for dr d theta. Where do we move first? And how? Is everybody okay with this derivative first here? So, since we're solving for dr d theta, we have to move everything that doesn't have a dr d theta. We subtract 1 over 2 both sides. Negative 1 over 2 theta. We have to get rid of this. How do we get rid of that? Since it's a rational, multiply by its reciprocal. Those cancel. So dr d theta, the 2's cancel, equals negative r to the power 1/2 over theta to the power 1/2. Derivative. Any one of those answers I'll take. Yeah, a lot of people staring. What are y'all staring at? Yeah, remember, the square root of x is the same thing as x to the power 1/2. Since these are 1/2 powers, that means they're radicals. Let's find a second derivative. Not of this. Something easier. X squared plus y squared equals 1. Find second derivative. Okay, let's go to this one. In order to find the second derivative, what do we have to find first? First derivative. So, the derivative of x squared is 2x. Derivative of y squared, good. And the derivative of 1, 0. So that's a solve for dy dx. 2x over. Negative 2x. If the dy dx by itself, we have to get rid of the 2y. How do we get rid of that? Divide by 2y. The 2's cancel, so we have negative x over y. That's our first derivative. Now we've got to find our second derivative. So the derivative of the derivative is d squared y. But we have to do the quotient rule. Negative x over y, negative 1. Derivative of y is dx. Very good. Y times negative 1 is negative y minus negative x times dy dx all over y squared. So that becomes plus. It's negative y plus x dy dx over y squared. Are we done? Yeah, Yeah, whenever I ask that, we're never done. What do we have to put in there? Yeah, the dy dx. Substitute that back in there. So dy dx is negative x over y. This is x over 1, so it's negative x squared over y. We have to get a common denominator on top, so what do we have to do? By y over y. Negative y squared over y. Positive and negative is a negative. Squared over y squared. Common denominator, so we have negative y squared minus x squared. The top fraction, leave it alone. Negative y squared minus x squared over y. Flip the bottom. So our second derivative is negative y squared minus x squared over y cubed. You said it perfectly. It's the algebra that's going to cause most trouble in here. What do y'all think about this one? Doable? Okay. Since we're running out of time, let's go ahead and combine the last 3 questions into one. Number 33, x squared plus xy minus y squared equals 1 at the point 2, 3. Find the equation of the line tangent to the curve at 2, 3 and normal to the curve at 2, 3. Find the equation of the line tangent to the curve at 2, 3 and find the equation of the line normal to the curve at point 2, 3. Find the equation of a line. What do you need? Slope. What else? Basic necessities to find the equation of a line. You need to have a slope and a point. We have a point. We just have to find the slope. How do we find the slope? The slope is dy dx. So we have to find the derivative of this function. Derivative of x squared is 2x. It's a product rule. Derivative of x is 1. Derivative of y is dy dx. So this one's going to be y plus x dy dx. Derivative of y squared is 2y dy dx equals 0. How many of y'all did that first? Did anybody else do anything else before this? Which you should have? If we would have had more time, I would have put a different point up here. Why does that matter? The first thing you have to determine is this point on this curve? I was going to put 3, 2, but I figured we only got 20 minutes left. So the first thing you should have done is plug it in there, see if this side equals 1, and it does. That's always the first thing you do. If it doesn't fit on there, you can't do anything with it because you can't find the slope of any point since you don't have a point. So with that, get the non-dy dx's on the other side. So subtract 2x, subtract y from both sides. So x dy dx minus 2y dy dx equals negative 2x minus y. Factor out the dy dx. X minus 2y equals negative 2x minus y. Divide by x minus 2y. So our derivative is negative 2x minus y, x minus 2y. What do we do with that? I'm sorry, the your answer is wrong. You do what with it now? Exactly. So this finds us the slope. The slope is negative 2. X is 2. Y is 3. That's negative 4 minus 3. 2 minus 6. So the slope is 7 over 4. Positive 7 over 4. This wrong. So what do we do with this? This and the point, we can find what? We need to put it in this form. We just don't have the y-intercept. So plug in everything else, solve for b. 3 equals 7 over 4 times 2 plus b. The 2 and the 4 cancel. 7 over 2 plus b. Multiply across the board by the LCD. We get 6. The 2's cancel. I multiply everybody by 2. Use cancel. So negative 1 equals 2b, so b is negative 1/2. That's my y-intercept. So equation of the tangent line is y equals 7 over 4x minus 1/2. That's the tangent line. How do we find the normal line? So the perpendicular slope would be flip the slope and change the sign. You would do the same thing. Plug it in there. Work it out? Why not? We have half an hour. We have the slope of the line normal to it, or orthogonal to it, and we have the point. We need to find the y-intercept. Negative 4 over 7 times 2. Negative 8 over 7. Multiply each term by 7. 21 equals negative 8 plus 7b. Add 8. And divide by 7. So this y-intercept is 29 over 7. With the slope negative 4 over 7. It's the normal line, which is perpendicular to the tangent line at that point.
So the first line is a tangent line.
First line is a tangent line, right? So yeah, whenever you find a derivative, it's always of the line tangent to the curve at the given point. And then from there we find the normal, we can find any other skewed line from there. Exactly, yes. So flip and change sign. Negative reciprocal, exactly. What do y'all think? So far so good? Horrible? Terrible? Or is it better than you felt an hour and a half ago? Or still mind full of mush? The next thing we're going to do, we're going to go backwards. We're now going to find the derivatives of inverse functions. Inverse functions and inverse trig functions. So that means in some cases we have to find the inverse and then take derivative, or use that to find the derivative of the whole function. All right, so that's it for today. Thank you. Have a great day. Adios.